Hello, I've just been doing some testing of this Follow Me thingy, which is where you have a GPS on the radio controller and a GPS on the car, and we're using an NRF24 module to send the GPS location of this to the car, and then the car will head towards wherever this is. So I did this a few years ago when I lived in Japan, but I was using plain old Arduino for that time. But what I'm doing here is implementing the same thing using the S-Bus mixer just to sort of test and see how everything's going to work and test the new nodes that I've been making and stuff. So let's just have a look at this. It's just a quickly slapped together piece of foam board, and we have S-Bus mixer in the middle, a little battery there to power it with 5 volts, and then we have a joystick. So this is basically just 2 variable resistors or potentiometers in there, one for vertical and one for sideways, and then it actually has a press button in it which I'm using to switch modes between manual mode and the Follow Me mode. As you can see, there's a little SW there on that last input. Then we have up here another potentiometer. This is for steering trim, which I found to be necessary actually. Then we have a NRF24 module there with a antenna, and of course GPS there to pick up the location. So this works quite nicely, but one problem is that this joystick thing is really shitty. Seems like they're not all made the same, these things. You get good ones and you get bad ones, and I bought a bunch of these a while ago and they are the bad ones for sure. And the problem is that there's a huge dead zone, so you move it like this and then nothing, 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 and then all of a sudden it starts moving all the way to the side. So it's kind of a nuisance, but it was okay for this test because mainly I just wanted to do the automatic mode. Over on here we have another S-Bus mixer and another NRF24 module with antenna going up to there, and we also have that GPS is it's not actually doing anything. It was just there from before something else I was doing, but the one we're using for this is a BN880 module, a little bit larger one, and this also has a compass inside it as well, which is necessary for the car to know which direction it's facing. And because we're dealing with quite a few hills here, I'm also using the accelerometer from here to give us the tilt compensation for the compass, which when I did this in Japan, I got away with not having to do that, and I didn't actually understand at the time that I would have needed it if I was on hills, but back then I was just on flat baseball pitches and car parks, and I just sort of didn't know that I was getting lucky. Okay, looks like we have a green LED, valid GPS lock on both of these. Now, like I said, the control with this dead zone here being so large is really horrible, so I'm not going to be doing much manual driving, but that's okay, it's not really the point of this video demonstration. Now I'm standing quite close to it, so with a bit of luck, if I do my push button, you can see it's trying to like come this way, but it's close enough that it's not actually going to turn the motor on. And when you're really close, you sort of get this indecisive movement from the steering wheel as well. But if I walk away a bit, now you can see it's more decisive about the steering, but I'm less than 2... Okay, I was going to say less than 2 meters away. But I've noticed that the GPS on here, this is a BN220, it's not quite as good as the BN880 on there. That one gets a fix really quick, and it seems to be more consistent, but this one, not so much. It's fine for a plane and quad and stuff, but when you're doing stuff where you're like just a couple of meters away, you really start to notice the difference in positioning between these two GPSs. Case in point. So now it thinks it should go over there. But when you put a little bit more distance between the 2 points, like this, it becomes less of an issue because the difference in angle is finer. Anyway, let's see if we can get it through the gate here. We'll walk out in the field. Oh, this way. Alright, so I'll just click the auto mode off, walk away a bit. We'll make it turn a corner here to come towards me in this direction.
Seems like it consistently wants to go a little bit to the east of where I'm standing with this GPS. Yes, hang on, you're supposed to follow me, not walk beside me. Although actually that's not too bad. Let's stay away from that hill there. That's way. It's actually, man, it's staying a lot closer to me than it was in my previous tests for some reason. Maybe I shouldn't be bad-mouthing this GPS too much. Actually, it's almost right on top of me. Look at this. Oh, shit. No. You're right. Okay, now we've got a nice flat open space here. So you see how directly it comes to me if I just stop it there. Now I'll go back. Actually, I'll turn it around so it has to actually, I'll turn it to face right away from me, and it has to do a 180-degree turn here. Yeah, that's pretty good. That's about 2/3 of the forward throttle range, that speed there. Yeah, happy with that. Something that I improved in this version from my old version is that we're now using the accelerometer for tilt compensation of the compass, up or down, but when we go down this hill here, we will have that problem. We would, if it wasn't being corrected for. Alright, it was not that much of a tilt, but it's a little bit of a tilt there. In fact, from what I've seen, that much of a tilt would be a good 20 degrees of error with my old system. Anyway, whoop. So how much is it off by now? Not bad. Not bad. Let's go back uphill. A little bit slower though, isn't it? Oh, that doesn't look like 2 meters. You okay? Oh yeah. That's a bit better. Let's see how well it can go along a road. This way. This way, good. Good. Okay, so this road here, I'll just let it get in the middle of the road first. That's pretty good. Now, going off to the side there. Oh, I was unconsciously walking this way to pull it towards me. So I guess it's not really quite good enough to stay on the road, is it? Although if I walk along this edge of the road, it'll probably be right. Just seems to be a small offset. Hello. You ever seen one of these before? Bet you haven't. It's automatic. See, look, I don't have to do anything. It just follows me like magic. Seems to be a bit better here. Now, see, if I'm in the middle of the road, it wants to go over there. But like I say, I'll just manually drive it for a bit. If you're further away, the angle calculations seem to be a little bit more forgiving. Yeah, so the further... Oh, what? No, it still wants to go that way. Well, not bad. Now I'm walking right over on the edge here.
Okay, that's about it for the demo, and the rest of this video is going to be just looking at how that was put together in the S-Bus mixer system. And to give you an idea of how long that's going to take, this is the transmitter side configuration, and this is the receiver side. So it's a little bit more involved than some of the other things that I've shown you in the past. And again, this is not going to be a tutorial or anything detailed. I just want to give you a broad overview, or to give you an idea of what it takes to get something like this running. Anyway, let's take a look at it, and I'll try not to get bogged down into looking at every little node individually. I'll just maybe look at like the large picture, like one of these blocks of logic sections at a time. So this section here takes our analog inputs from the throttle and steering, that's the joystick, and we also have a digital input from the button. And we have a bunch of logic here which decides whether we should be in autonomous mode, the follow me mode, or manually controlled mode. And that's stored in this store node there, depending on the input. And the way this works is that if either the throttle or the steering excuse me, is moved away from the center, then that cancels the autonomous mode. And then down here we have we have another analog input for the trim pot, and that just goes through a couple of simple binary operators, and then that gets added to the steering. And I just noticed while I was setting this up for the video that I'm taking this node called steering, which is that one, and I put in some RC Expo to both the steering and the throttle to try and improve the behavior of that terrible joystick with the huge dead zone. And I was puzzled about why it didn't work, like my RC Expo didn't really fix anything, and I just realized it's because I'm taking that one instead of what I should be doing, which was taking that one like that after the Expo. So that was kind of dumb of me, wasn't it? Then over here we have a bunch of outputs, and these are going to the NRF24 module, and we have 6 channels, is there? Yeah, 6 channels. So you have throttle, and again, this is before I added the RC Expo, so I should have the RC Expo one here, not throttle. And this is channel 1, steering is on there, mode, and then we have a couple of inputs coming from the GPS. So this is the GPS on the transmitter, right? And we're sending that to the car over channel 4 and 5. And then we're also sending this valid field, and this is something that I've kind of arbitrarily decided that when you have a fixed type of 3, which is a 3D fix, and you also have 6 or more satellites, we deem that to be valid. So that's just one of the things that you could select as the value that you want to pull from the GPS. So we can have, you know, hour, minute, second, heading, speed, all that kind of stuff. So valid is just one of those things. And then we're using that to say whether we want the LED to be red or green on LED 1. So that just lets us know visually whether we have a GPS fix on the transmitter. But we're also sending that to the car in channel 6, and the reason that we're sending it so that the car also knows whether the transmitter has a valid fix, because if we don't have a valid GPS fix on both ends of this thing, the car could just drive off to, for example, lat long 00 in the middle of Africa or somewhere like that, and we don't really want that. And the last thing we have here is just LED 2 should be purple when we're in autonomous mode. And I think that's all we have here, although there's a little bit going on here extra for these NRF24 channels, because some of these channels, it's okay just to use 1 byte of data. For example, this throttle and steering mode. This one here, the mode, could actually be just 1 bit of data, but we're using 1 byte. However, lat long, that can't be stored in 1 byte, so we need to use a full 32-bit float for that. And the way we organize this, we could just make them all floats, but that's a little bit wasteful of the potential of the NRF24 module. So what I've done, if I just go here, the way things are set up is you need to define a format like this for the channels that you want to send. So I've got B, 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 F, F, B. So these are byte, 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 float, float, byte. And the reason this is done as a typed in text field here like this, instead of selecting from features like pull downs like that, is, for one thing, it's handy to be able to put a name on there like that, but also it makes it easier just to copy and paste that, because we need to take this exact same format on the receiving side to make sure that it's going to work. So this is a transmitter here. Alright, let's go over to the receiving side, and I'll just show you that on here again we have exactly the same format for our NRF24. Speaking of which, let's start here. We have inputs this time, and they're all of value type channel, or not all of them, but this one is a value type channel, channel 1, and then steering mode. So basically just what we had on the transmitter, except I've changed the names of these a little bit here, and I've made sure that it says transmitter latitude, transmitter longitude, to differentiate it from the car's lat and long. So this is running on the car, right? This is the receiver. This is just to remind me that these values here are the transmitter location, not the car location. And also this is the transmitter GPS valid value. And then the last one down here, you'll notice that the value type is not a channel, it's an age. And if we go over here and look at what properties or what options we have for that. So channel is what all those other ones are. And we can also have age and packets per second. So packets per second will give you an idea of how good the connection is, how many packets per second you're receiving. And then age is the time in milliseconds since the last packet was received. So this is typically about almost 0, basically, if everything's working well. And I'm taking that, I'm comparing it to 1000, which is 1000 milliseconds, so this is 1 second. And if the signal age is less than 1 second, we deem that to be that we have the signal. So this is just useful for a fail-safe condition to check. If we haven't received something from the transmitter for a while, then we go into a fail-safe state. That's about all that needs to be said for those. Up the top here we have just another LED on the car, and this is going to be changing from red to green when we get a GPS fix. That's all that does. Next bit down here, we need to decide whether the car should be running manually controlled or in the autonomous driving mode. And the conditions are, as we said, we want to have both the GPSs valid, so that's the transmitter GPS and the car GPS valid. Car GPS valid, where's it coming from? Oh, that's this one here, yeah. And then we need another AND condition to say that the transmitter wants to be in autonomous mode. So I probably should have called that one autonomous mode. Anyway. So if those conditions are true, we come in here and then we have a selector which is going to select based on that whether we have auto throttle or just throttle. So the just throttle is the manual control one. And then down here same for steering as well. And then we also have to think about the failsafe, because regardless of what any of this other stuff's doing, if we don't have any current signal coming in from the transmitter, we just want the car to do nothing at all. So we test for the have signal one that we saw before. That's that one. So if we have a signal more recently than 1 second ago, we pass this value through like that. Otherwise we just set it to 0.5, which is the middle of the range for both steering and throttle. And then we have Servo Pwm Outputs for ESC and the steering servo over there. So we've used a couple of things here that we haven't looked at yet. Or throttle we looked at and steering we looked at. Those are just coming directly from here, the inputs from the radio directly. But we have auto throttle and auto steering, which we have yet to look at. So that's what these two sections are down below. And to figure this out, we're using a node called GeoCalc, and this takes a latitude and longitude as parameters, and it calculates in this case the distance to the given parameters from where this GPS currently is. So this will say, for example, we're like 50 meters away from the transmitter, and that's used to decide whether we need throttle if the distance is more than 2 meters. And then again we're using, what was that one? This one here. So whether, depending on whether both GPSs are valid and the transmitter wants to use autonomous mode, we're going to either use use that, or we're going to use 0 throttle. And then we just slew it so that if you let it immediately start the throttle, the car kind of kicks up, and it doesn't really flip over backwards. It doesn't quite have that much power, but it just makes a very violent movement on the motor and the gears and everything, and I didn't really like that. And it also, if you're on a slope sideways, it tends to kind of tip the car over quite often. So I just, instead of having the throttle come on suddenly, I wanted it to take 1.5 seconds to get from 0 to, well, not full throttle, but a third throttle like that. And then when it's turning off, we don't have to worry about that. So the slew for cutting the throttle is just 0 seconds. It just immediately turns the throttle off, and it just kind of rolls a little bit. Then we just have a couple more simple binary operators to get that in the right range for passing it to the ESC. And then down here we have kind of a similar situation for the heading, but now we are using a bearing to the desired lat long, and we need to compare or take the difference between the desired heading and the current heading, which we get from the compass. Now this is actually the main reason for doing this test in this whole video, because I added this node, and it's kind of a pain in the butt actually, more than I thought. I added a barometer node, and it took 1 day of work, easy. This, with all the calibration and all the nonsense that goes on with the tilt compensation and everything, not so easy. Anyway, it's done now. So we take the difference of those, determines which way we want to turn the steering wheel, and then we want to wrap this into this range so that 0 is going to be straight ahead, negative 180 is going to be to the left, and positive value is going to be to the right. Starting to get into the details a little bit too much, but anyway, we scale that. And then I also found that this is not strictly necessary with this car really, but I didn't like the way that when it was turning, if it was at full speed or it was traveling fairly quickly, and then it decided that it wanted to do a U-turn, it could kind of almost flip over. I didn't actually see that too much, but I saw that quite a lot with the car that I was using in Japan, so I thought it might be a good idea to just add this here, which is going to take the steering direction, and it's not going to let it do a full lock steer to one side or another if it's moving too fast. So that's what these 3 nodes are doing here. If it's moving, the faster it's moving, the less it's able to turn the steering to one side. And then that just goes out here with a little bit more of a shift by 0.5. What else have we got to look at? Oh, then we just have some lights. So again, we just turn LED to purple if we're using the autonomous mode. And to make it obvious to the user that the fail-safe condition is in effect, we take the value of have signal and we invert it, so now it's like no signal. And we use that to activate LED 3 with this color called flashing red, which is using a strobe. And starting to get into the details a little bit much here, but you're still watching, so hey, might as well, eh? So this has a pattern here, and it's a very simple pattern because all we're doing is turning this LED on and off with equal timing. You can actually have more of these little pips here, and you can tell it to flash in this certain pattern. So this is what I was using to get the aircraft strobe lights pattern in my previous video. But like I say, if you're only turning it on and off in equal timings, you really only need 2 of those. And then this time scale stretches it out, and we can put an interval wait time between them and so on. And the color is going to be red. But it's only active when we have no signal. So I think that's it. So there's a fair bit to it, but thanks for watching, I guess, and let me know if you have any questions or comments or I don't know, suggestions even. Might be interesting. But that's how the system's shaping up at the moment. And the reason that I'm not really doing any detailed explanations is because there's quite a few things that are still in flux and might change sometime in the future, and I don't want to sort of lock everything in with like a tutorial, especially since there's there's no way to get this thing for anyone at the moment anyway. But hopefully that was interesting. So thanks for watching. Bye.